Hi everyone, my name is Yang and I cooperate with Zihao and Yihui to finish our team project. Our project focuses on enhancing the face recognition robustness with random erasing data augmentation. First, let me introduce our project. The objective of our project is to improve the robustness and generalization of face recognition models under the occlusions and varied conditions. And our motivation is to use the random erasing techniques to address the challenges posed by occlusions in face recognition. There are already lots of related works, such as the studies on traditional data augmentation techniques like random cropping and flipping, and also the introduction to the challenges with occlusion in face recognition. So to address this problem, we find a method called random erasing, and we also read some related papers. For our own project, we use two data sets. One is LFW, which is the labeled face in the wild, and another is yield face database, which also includes many human face data. Our basic model is the simple CNN, which is widely used in face recognition. So apart from the basic CNN, we also applied both dropout and random erasing to reduce the overfitting in our training process. And we used various metrics such as accuracy and loss to evaluate the model performance.
So now this is the how. Let's move to the project workflow as well as the milestones. So understanding the previous related works as well as how we design and choose our database, the main objective of this project is to implement and evaluate a facial recognition model enhanced by this random erasing data augmentation. And we basically just define a simple CN with yield class and configure the model for various training phases. And we compare the baseline as well as the dropout versions of the model, which were trained across 10 epochs for each. And here are some of the preliminary results. And this is for the LFW data sets. And as you can see that the baseline model achieved a training accuracy of 98.75% and the validation accuracy is 51.25% after 10 epochs, which indicate a potential overfitting without the dropout. And that's why we introduce it. So the model with dropout, which is a 0.5% training, has a lower training accuracy, but the validation accuracy improved slightly, which is just a better generalization of unseen data. And the model that comes with random erasing has a validation accuracy improvement, stabilizing around 68.75%, while the test accuracy reached up to 67%, demonstrating the model is enhanced ability to handle unseen data. And next, let's see how the model works on the yield datasets. And unlike the previous one with LFW datasets, we can see that the baseline model achieved a training accuracy of 93.64% and a validation accuracy of 84%, which is still indicating an overfitting. But with the dropout, we can see that the training accuracy was lower, but test loss has improved slightly, which is just a better generalization on unseen data. And the model that comes with random erasing validation accuracy goes even lower, around 76%, while the test loss decreased to very low, which demonstrates that the model is slightly enhanced ability to handle unseen data.
For the challenges and adjustments we made, and the challenges we encounter when we doing this project is that overfitting, which is a significant challenge with the baseline model, as indicated by high training accuracy but lower validation performance. And initial dropout setting requires tuning to balance between underfitting and overfitting. So for fixing them, we try several adjustments. The first one is to include the dropout regularization to significantly help in reducing the overfitting. And another adjustment is that we adjust the learning rate and training durations were made to optimize performance across training and validation phase. For the next step and future work, And we want to explore additional arguments, techniques like geometric transformations and noise injections to further robustness. And consider using a deeper or different architecture to improve the learning as capability and accuracy of the model is also one possible way to go. For the evaluation plans, the first one is to extend the testing to more diverse data set to evaluate the model's generalizability. And it can also be done by further tuning of hyperparameters to optimize both training and validation accuracy. In conclusion, so our achievement is that we successfully implement and evaluate an CNN model with random erasing arguments. And also we demonstrate improvement in model robustness and generalization through dropout regularization. And the impact on the future research is that the findings encourage further explorations of dropout and other regularization techniques in enhancing facial recognition models. And that's the summary of our whole project. Thank you.